Hey developers! Welcome back to the channel. Today we're diving deep into one of the most powerful technologies behind modern AI applications, semantic search engines. Whether you're building the next ChatGPT-style application, an intelligent product search, or a smart document retrieval system, this tutorial will get you there. We'll be covering 3 industry-leading vector databases, Pinecone, Milvus, and Weaviate. By the end of this video, you'll have a fully functional semantic search engine that understands meaning, not just keywords. So grab your coffee, open your IDE, and let's build something incredible together. Let's start with the fundamentals. Traditional search is like a very literal librarian. If you search for car repair, it only finds documents containing those exact words. But what if someone wrote about automobile maintenance or vehicle fixing? Traditional search would miss these completely relevant results. Semantic search is like having a brilliant librarian that understands context, intent, and meaning. It knows that car repair, automobile maintenance, and vehicle fixing are talking about the same concept. The magic happens through something called embeddings, high-dimensional vectors that capture the semantic meaning of text. Think of these as DNA for meaning. When we plot these vectors in high-dimensional space, similar concepts cluster together. This is how we can find semantically related content even when the words are completely different. Now you might wonder, why not just use a regular database? Well, imagine searching through millions of high-dimensional vectors in real time. Your traditional database would crawl to a halt. Vector databases are specifically engineered for this challenge. They use advanced indexing algorithms like HNSW and IVF to make similarity searches lightning fast. Today we'll explore 3 powerhouses: Pinecone, fully managed zero-ops vector database; Milvus, open source with massive scalability; and Weaviate, vector database with built-in ML models. Let's look at our architecture. We have 4 main components: your data source, an embedding model, the vector database, and your application layer. Here's the workflow. 1. Documents come in. 2. Embedding model converts them to vectors. 3. Vectors get stored with metadata. 4. User queries get vectorized. 5. Similar vectors are retrieved. 6. Results are ranked and returned. First, let's set up our environment. I'm using Python 3.8+, and we'll need different packages depending on your chosen database. I'm also using sentence transformers for local embeddings, but you can absolutely use OpenAI's API if you prefer. Let me show you both approaches. Let's start by creating our sample dataset. I'm using a customer support FAQ, but this could be product descriptions, research papers, or any text data. Now let's load our embedding model. I'm using All-Mini LM-L6-V2. It's fast, efficient, and perfect for getting started. Time to generate our embeddings. Watch how each piece of text becomes a 384-dimensional vector. Here's something cool. Let's visualize the similarity between our FAQ items. Notice how related questions cluster together? Let's start with Pinecone. Head to pinecone.io, create a free account, and grab your API key. The free tier gives us plenty to work with. Now we'll create our index. The dimension must match our embedding model, 384 for Mini LM. Time to upload our vectors. Pinecone expects data in a specific format: ID, vector, and metadata. Now for the magic. Let's perform our first semantic search. Now let's explore Milvus, the open-source powerhouse. I'm running it locally with Docker, but you can use Zilli's Cloud for managed hosting. Milvus requires us to define a schema up front. This gives us more control and better performance. Let's insert our data. Milvus handles batch operations efficiently. Milvus gives us fine-grained control over search parameters. Finally, let's explore Weaviate. It's unique because it can handle vectorization automatically, but we'll use our own vectors for consistency. Weaviate uses a schema-based approach with classes and properties. Think of it as a graph database for vectors. Weaviate has excellent batch import capabilities. Let's use them for efficient data loading. Weaviate uses GraphQL for queries, which gives us incredible flexibility. Now let's talk optimization. Each database has unique strengths for different use cases. One powerful technique is hybrid search, combining semantic similarity with keyword matching for the best of both worlds. For production systems, monitor these key metrics: query latency, index size, memory usage, and relevance scores. When scaling up, consider batch operations for bulk updates, horizontal partitioning for massive datasets, caching frequently accessed vectors, and A/B testing different embedding models. Let's see where this technology shines in the real world. Retrieval augmented generation, the backbone of ChatGPT, Claude, and other AI assistants. They use semantic search to find relevant context before generating responses. E-commerce platforms use semantic search to understand queries like comfortable running shoes for flat feet and find relevant products even if descriptions don't match exactly. Developer tools like GitHub Copilot use semantic search to find relevant code examples and documentation. Incredible! We've built semantic search engines with 3 different vector databases. You now have the foundation to build AI-powered search into any application. Here's what to explore next. Experiment with different embedding models, try multimodal search with images and text, build a full RAG application, explore vector database clustering and sharding. If this tutorial helped you, smash that like button and subscribe for more AI development content. What kind of semantic search application will you build? Let me know in the comments below. Until next time, keep coding and keep building amazing things.